For lesson 2 of chapter 2, we're going to solve one-step equations. So first we'll solve equations using adding, subtracting, dividing, and multiplying. We'll solve equations using reciprocals then, and then write and solve an equation. First we need to solve for x, and we've done this before so I won't spend too much time on the theory behind it. Remember, for the goal for these equations is to isolate the x or get it all by itself. And for these adding and subtracting problems, the best way to do that is to add the opposite. So for the adding one, instead of x plus 7, we would add negative 7 to both sides. We have x is plus 0 now, so x equals, and then positive 4 and negative 7. Well, the negatives win by 3, so it would be x equals negative 3. Here we'll add the opposite as well. So we have 3 equals negative 12 plus x. Add the opposite of negative 12, which would be positive 12. Add that to both sides then. So we'd have 15 over here equals x. Now we have multiplying and dividing. So we have negative 6 times x equals 48. Well, multiplication and division are inverse partners, meaning that if I divide by negative 6 on both sides, that'll isolate the x. So let's divide by negative 6. So that would give me positive x over here, and then 48 divided by 6 would be 8, but then it would be negative 8 because there's only one negative. Now we have 5 equals x divided by 4. So the inverse of dividing would be multiplying. So times 4, multiply this times 4, and then these would cross out, and then this would turn into 20. So we would have 20 equals x, or x equals 20. Let's solve using reciprocals then. Whenever we have these fraction equations, negative 2/7 times x equals 4, whenever you're multiplying times the fraction, you can always just divide by the fraction, right? And then instead of doing all that extra rigmarole, we can just multiply times the reciprocal, because we know that dividing a fraction, you multiply times the reciprocal. So we would have the reciprocal of negative 2 over 7 would be negative 7 over 2. And we would do that to both sides here. So negative 7 over 2. Okay, and then this would be 4 over 1. So this would isolate the x because the negatives cancel out, and these would cancel each other out. So we're left with x over here. Now we have 4 times negative 7, that would be negative 28. 1 times 2 would be 2. Let's simplify that again. They could both be divided by 2, so x would be negative 14. Now let's do this one. So 5 6 is being multiplied times x, so I'd multiply both sides by 6 over 5. And do that over here too. So this would cancel each other out here, if you see that. 6 and 6, and then 5 and 5. So we'd have x equaling 10 times 6, which is 60 over 5. Then we'd simplify that even more, divide them both by 5. That would be 12 over 1, or just 12. So x equals 12. Now let's write and solve an equation. So in the 2004 Olympics, Sean Crawford won the 200-meter dash. His winning time was 19.79 seconds. So find his average speed to the nearest tenth of a meter per second. So no matter what, he's going to be getting 200 meters, right? So 200 meters, or just 200. So if he traveled in a total time of 19.79 seconds, what's our rate, or what's our speed, right? We need to find his average speed. So we'll do S for speed. So 19.79 seconds times the speed equals 200 meters. So we divide both sides by 19.79. And that would give us 10.1, let's see, to the nearest tenth, right? So it'd just be 10.1 meters per second.